Determine the area under the standard normal curve that lies to the left of the following z-scores. So we have a normal curve. They give us a z-score, which is a positioning, so they give us some number here, right? Some z-score, and then we need to know the probability or the area associated to the left of that number. So to do this, we're going to use the calculator. There's something called the z-score chart, which I would go over in class, but it's rather complicated. So we're going to stick to the calculator. I'm going to show calculator-based methods for everything to keep it more simplistic, more streamlined. So we're going to find the probability or the area that lies under the curve to the left of the z-score value, negative 3.49. In the calculator, what you need to do first is hit your second button and then the vars, which is right under your directional pad, because we need to get to distributions. So now in distributions, I have a PDF and I have a CDF. PDF, remember, was for exact values. CDF is anything less than that idea. So we're going to need to go to number 2. Now that I'm in the normal CDF, I need to start with my lower bound number. I need the lowest possible number that I can go to. What I usually do is just make a really big negative number. So I say negative 1 E99. That's some gigantic negative number. So that's something way over here. Then my upper bound number is my z-score number. So I'm going to type in negative 3.49. Then I need to do my average. For a z-score normal distribution, our average will always be 0 and our standard deviation will always be 1. So anytime we have a z-score, these two numbers will not change. So once we have that, we simply hit enter. Oh, go to. I probably put a negative sign. Yep. Subtraction. Common mistake. It's okay, we can fix that. So now they're both negatives. We hit enter. That gives us our area. That gives us our probability. We get 2.415552975 e to the negative 4. Again, e to the negative 4 means we have a really tiny number. So the area associated with this value, 0.0002. There's your answer. That's it. So let's do it again. For B, find the area that lies to the left of z equals negative 1.99. So we're going to hit second, vars, which is distribution, CDF. We're going to hit lower bound number, negative 1 e to the 99. Our upper bound number is where we're going to stop, so this negative 1.99. Average, which is 0, and a 1, which is our standard deviation. Hit enter. There's our area associated with that value. So 0.0232. C. Same exact process. We've got to get used to this calculator. So we're going to hit second, distributions, normal CDF, lower bound number, negative 1, e to the 99, 0.92, average, which is 0, standard deviation, which is 1. There's our area associated with that value. So z equals 0.92. The area associated with the probability associated with it is 0.821. Finally, for our last one, same exact process. We're going to hit the second vars for the distributions, go down to normal CDF, start with our lower bound number, negative 1 e to the 99. Our upper bound number, that's where we're going to stop at, 2.90. our average, which is always 0 for a z-score, and our standard deviation, which is always 1. Enter. There's your probability. There's your area associated with that z-score value, 0.998. Now, we just determined the area underneath the standard normal curve, or the probability, right? This means probability as well. Area and probability are the same thing with the standard normal curve.